So this next segment is about segments, rays, midpoints, and bisectors. There's lots of definitions in geometry, so it's good to keep a list of them that you can refer to as needed. So first of all, what is a segment? In geometry, a line segment is a part of a line that is bounded by two distinct endpoints and contains every point on the line between its endpoints. It's as if you took a line and you just took scissors and snipped a piece of it off. So this here is segment AB. You can see that it now has definite endpoints. There are no longer arrows at the ends. You name a segment by any 2 points on that segment, and you name it by a segment symbol over these letters. So it would look like this, segment AB. So you just put a line over, or I should say a segment over the letters AB. Notice that there's no little dots on the end of the segment symbol. You can just put this little segment on top. You could also call it BA because you just have to name it by any 2 of the points. All right, so what is a ray? In geometry, a ray is a portion of a line which starts at a point and goes off in a particular direction to infinity. So here's an example of 2 different rays. You see that they have definite starting points. So this has an end point here of A, and the one on the right has an end point of B. And they have an arrow on only one side of the ray. You name a ray by 2 points on the ray, always starting with the end point. You name it by a ray symbol over these letters, and in the ray symbol the arrow will always be pointing to the right, regardless of the direction of the ray. So the one on the left here, this ray on the left with an end point of A, you would name this ray AB, and you can see this little arrow has an arrow only on one side, and it's to the right. This next one here on the right has an endpoint of B, so we'll name this one ray BA. This tells you that it starts at B and it's going towards A. The points of a line can be put into a 1-to-1 correspondence with the real numbers so that the distance between any 2 points is how far it is from one point to another. Well, that's a lot of words, but let's see what this really means. This is just saying that if I have a number line and I call this first point A and I designate it's going to be starting with number 2, and I have another point over here, point B, which is designated with number 5, I can determine how far it is from A to B by simply counting how many jumps I have to take to go from A to B. So the length of AB would be 3. 1, 2, 3. Another way to determine this is to take the higher number and subtract the lower number. So 5 minus 2 gives me 3. So I know the length of segment AB is 3 units. All right, let's look at an example. Find QS if the coordinate of Q is -3 and the coordinate of S is 2. So let's think of this like a number line and let's draw it out. Anytime you have a problem in geometry, it's always a good idea to draw a picture. So here's my number line. I have Q is at -3 and S is at 2. Well, I know that I can find the length of QS simply by taking the larger number and subtracting the smaller number. So I can take the larger number, which is 2. I can subtract the smaller number, which is -3. Well, if you remember, when I have 2 negatives together like this, it makes a plus. So I really have 2 plus 3. So I know that QS is 5 units in length. You can check this by checking the jumps. 1, 2, 3, 4, 5. There are 5 jumps to get from Q to S. Here's another example. Find AB if the coordinate of point A is -8 and the coordinate of point B is 11. Well, we know that we're going to take the larger number 11 and subtract the smaller number, which is negative 8. So 11 minus a minus 8 would give me 11 plus 8, or 19. So I know the length of segment AB is 19 units. Let's define another word, congruent. Two segments with the same length are said to be congruent. It means they have the same measures. Here are two segments, segment AB and segment CD. You mark them congruent with these little tick marks. So I put 2 tick marks on AB and 2 tick marks on CD, and those tick marks indicate that the length of AB is equal to the length of CD. And you can use 1 tick mark, 2 tick marks, 3 tick marks, however many you need, but whichever one you're showing it's congruent to should have the same number of tick marks. So if AB equals CD, then segment AB is congruent to segment CD. So this little equal sign with the little tilde on top is the symbol that we use to show that two things are congruent. So if I have a figure like this, I drew a quadrilateral and I put some tick marks on it. This shows that the opposite sides are congruent. So the top and the bottom are congruent, and the right and the left side are congruent. The segment addition postulate says if there's 3 points on a segment, for instance, A, B, and C, and they are collinear, so you remember collinear means that they all lie in the same line, and B is between A and C, then AB, this little segment AB, plus the segment BC has to equal the whole segment AC. So let's see how we'll use this in an example. Point S is between points D and T on segment DT. DS is 20, ST is 15, and they want you to find the length of DT. So once again, let's draw a picture. So let's draw DT and put point S somewhere in between D and T. It does not say that it's in the middle, so I'm purposely not putting it in the middle so that doesn't skew the way I'm looking at the picture. The next thing I want to do is I want to put the information they've given me on my drawing. So they told me that DS was 20, so I'm going to put 20 there. ST is 15, so I'm going to put 15 there. And they're asking me to find the whole length DT. Well, the segment addition postulate tells us that DS plus ST has to equal the whole segment DT. Let's just substitute in the numbers for what we know. We know that DS is 20. I know that ST is 15. And I don't know DT. That's what I'm trying to solve for. Well, 20 plus 15 is 35. So I know that DT has to equal 35. Let's look at another example. Point S is between points D and T on DT. DT is 40, ST is 12, and they want us to find the length of DS. So once again, let's start with drawing a picture. I have DT, and I've put point S between points D and T, again, not in the middle because it doesn't say that it's in the middle. DT is 40, so now it's telling me that this whole long segment is 40 units. It's telling me that ST is 12 units, and it wants me to find the length of DS. So once again, the segment postulate tells us that DS plus ST has to equal DT. Let's plug in what we know. I don't know DS, that's what I'm trying to solve for, so I'll call that X. I know that ST is 12, and I know that DT is 40. Now I have an equation that I can solve. I'm going to subtract 12 from both sides, and I know that X is 28. Therefore, the length of DS is 28 units. Here's another example. Point S is between points D and T on dt. If dt is 60 and ds is 2x minus 8 and st is 3x minus 12, they want you to find the value of x and then find ds and st. So there's a lot going on here, but again, let's start by drawing a picture. Here's dt. I'm going to put s somewhere between those 2 points. I'm going to put in what I know. I know that dt is 60, so I know this segment here is 60 units. ds is 2x minus 8. Well, I don't know what x is, but I'm going to still write that in, 2x minus 8. I know that st is 3x minus 12, so I'll put that in, 3x minus 12. The segment addition postulate tells us that ds plus st has to equal dt. If I substitute in what I know that ds is 2x minus 8. I know that st is 3x minus 12. And I know that dt is 60. Now I have an equation that I can solve. Let's combine like terms. 2x plus 3x will give me 5x. Negative 8 minus 12 will give me minus 20. And I can set that equal to 60. I'm going to add 20 to both sides to get x alone. I'll have 5x equals 80. And if I divide both sides by 5, I'll find that x equals 16. So I answered the first question, find the value of x. I found out that x was 16. But it also wants me to find the length of ds. Well, I know that ds is 2x minus 8. And I know that x is 16. So let's substitute 16 in for x and then solve this equation. 32 minus 8 is 24. So I know that ds is 24. But it also wants me to find st. Well, st is 3x minus 12. I know that x is 16, so I can substitute that in. I have 48 minus 12, which is 36. A good way to check your work is to make sure that when you add 24 and 36, you get 60. All right, let's talk about a little more vocabulary. Midpoint and bisectors. Let's start with what a midpoint is. So the definition of midpoint is a point that divides the segment into two congruent segments. So now you have segment BA, and this point M is in the middle or the midpoint of the segment. You're going to show that those two pieces are equal to each other or congruent to each other by putting the tick marks on it. So now you know that BM has to equal MA because it told you that M is a midpoint. If it's a midpoint, it's going to break this segment into two equal pieces. So if I said that AB was 10, you would know that BM has to be 5 and MA has to be 5 units. Let's look at an example. Point S is the midpoint of DT. DS is 3x minus 1 and ST is 2x plus 5. Find the value of x. Let's draw a picture. Here's segment DT. But now I'm going to put point S is the midpoint. So now I am going to put it in the middle. And I'm going to show it's in the middle by marking these two segments congruent. So I know that DS has to be congruent to ST because S is the midpoint. I'm going to write in what I know. DS is 3x minus 1. ST is 2x plus 5. Well, because S is the midpoint, I know that DS has to equal ST. I can now substitute the values into this equation. 3x minus 1 equals 2x plus 5. And now I have an equation that I can solve. I'm going to add 1 to both sides of the equation. I'll have 3x equals 2x plus 6. To continue solving this, I can now subtract 2x from both sides. And I'll have x equals 6. It's always a good idea to ask yourself, does my answer make sense? So let's go ahead and substitute 6 back into these two expressions and see what happens. So if I substitute 6 into the first one, I get 3 times 6, which is 18, minus 1, which is 17. And if I substitute it into the second expression, I'll get 2 times 6, which is 12, plus 5, which is 17. So 17 equals 17. Those two segments are congruent. My answer makes sense. All right, let's talk about bisectors. So the definition of a bisector is a line, segment, or ray that intersects a segment at its midpoint. So here's a picture. I have segment PQ and I have segment AB, which is bisecting PQ, which means it is going through segment PQ at its midpoint F. You can say that AB bisects PQ, or you can say that AB is a segment bisector of PQ. All right, let's look at an example. Segment AB bisects segment PQ at point F. If PQ equals 28, what is the measure of PF? So let's begin by drawing a picture. Here is segment PQ. Point F is the midpoint, so I put it in the middle. And AB bisects PQ at its midpoint. It tells me that PQ is 28, so I know the whole length of PQ is 28. But I also know that PF has to equal FQ because AB is a bisector, which means it's breaking this segment up into two equal pieces. Well, if PQ is 28 and the two segments have to be congruent, I know that PF and FQ have to be 14 units. It would have to be half of the 28. All right. Please complete worksheet 1-2, and if you have any questions, don't hesitate to ask.